I often describe software development as an exercise in learning. I think that this is true in some important ways. I usually talk about this in the context of being more experimental and applying scientific style thinking to solving problems in software. After all, science is humanity's best approach to learning, so it makes sense. But there's another aspect to being great at learning, and that's other people. What does it mean for a team to become better at learning? Pair programming is one of the most powerful techniques that I know of to liberate learning in teams. So let's explore what pair programming is and why it can make a difference to your team. Hi, I'm Dave Farley of Continuous Delivery. Welcome to my channel. If you haven't been here before, welcome. If you enjoy the content, please hit subscribe and hit the notification icon so that we can keep you informed of new content. Pair programming is probably the most extreme of extreme programming techniques. It was described first by the C2 team, the project in which Kent Beck and others invented extreme programming, the agile discipline, and was described in Kent's fantastic book Extreme Programming Explained at the end of the 90s. Wikipedia describes pair programming as an agile software development technique in which two programmers work together at one workstation. One, the driver, writes code, while the other, the observer or navigator, reviews each line of code as it's typed in. The two programmers switch roles frequently. I think that's a reasonable description of what it is that we're talking about. The other thing that I kind of like, which comes from the Extreme Programming book, is this diagram, which shows pair programming and its relationships to the other extreme programming practices. I think with the benefits of a couple of decades of hindsight and practical experience, I'd tend to put pair programming closer to the middle of this picture now. I think it's one of those things that really acts as the grease in the wheels between nearly all of the others. It makes all of those others easier to practice. So this collaborative way of working can bring many benefits. It can allow us to explore ideas collectively. It can allow us to find the better ideas, but also it allows us to learn from one another. This is all very nice, but why really do we need to bother? Well, software development is a creative discipline. For most people, creativity is amplified when we share that creativity and get to bounce ideas off other people. Software is technically difficult, it's fragile, so having somebody else review our work is a really good thing. Traditionally, we'd approach that part of the problem with ideas like code reviews, and they're very good things. Having a second opinion can be a big help. But there's several problems with conventional reviews, particularly when we start considering them in the realm of continuous integration and continuous delivery. We create better software when we proceed in a series of small steps. If I'm working well, I'm usually committing my changes once every 10 or 15 minutes. I'm going to write a test and see it fail. I'm going to write some code and see it pass. I'm going to refactor the two and then I'm going to commit. This is what continuous integration is really all about. Those frequent small commits. If I'm committing every 15 minutes or so, it really is quite impractical of me to go and interrupt a co-worker and ask them for a review for the 9th time this morning. I'm going to annoy my friends very quickly if that's what I do. So now either I don't commit as often, breaking continuous integration, or I commit often, but I have code that is not reviewed. Neither of these is a great outcome. So I could cure that by having some form of always-on review. Pair programming. The result of this is that a measurable increase in the quality of the code that we produce. All of the studies that I've ever seen show this increase in quality. Why is this the case? Well, the studies show that pairs evaluate more options than people working alone. I guess that's fairly obvious why we're going to, if we're working alone, we're just going to pick an idea and think, oh, well, that sounds good, and we're going to go ahead with that. If you and I are working together, I'll come up with an idea and you're going to say, well, that's okay, but what about this better idea? And then we'll discuss. So we have more options. We tend to evaluate more choices. But I think there's a more prosaic truth here. If I'm having a bad day and you are my pair, you'll lift up my performance a little bit. But even if not, your performance will be better and make a stronger contribution to our output as a pair. So we can smooth out one another's low points in our working practice. Equally, if you are flying and all of your ideas are great, we can take those great ideas. So we also get to level up the best ideas. So we kind of smooth out the troughs and level up the peaks. So overall, our performance improves. The data is also pretty consistent in showing that pairs produce simpler solutions. Again, this is pretty obvious. If I have to explain in detail all of the time my solution to you, there's a small pressure on me to make sure that my ideas are explainable and so simpler. This all sounds great, but there's an elephant in the room, right? The pointy-head boss is going to ask, why should I pay 2 people for the work of 1? Well, that is more interesting and less obvious than it looks. Most academic studies of pair programming have been done on students. There's a good reason for this, because students are cheaper to experiment on. The data from academic and metadata studies of projects is fairly consistent, though, for both of those classes of data. On average, 2 people will complete a task in about 60% of the time of a single person working alone. So 2 people are nearly, but not quite, twice as fast. So, aha, says the pointy-head boss. You aren't justifying 2 people working together. But then we have to take into account the quality of the work that's produced. And again, consistently, studies show that people working in pairs produce higher quality output than people working alone. The tricky part here is, how do you evaluate the impact of quality? And there are all sorts of ways in which that plays in. There's if we produce higher quality code, we're going to have fewer defects in production, which means we're going to spend less time fixing them. But also there's just the overall impact, the maintainability of the system, our ability to work and change it, and those sorts of things. I don't have any data on those apart from the State of DevOps report reported in the Accelerate book. Overall practices, if you add them all together, you see a big hike in productivity of teams that produce higher quality work more consistently. But if we look at the simple measures of quality from pair programming studies, they're pretty consistent. Here's some data from a series of experiments, and you can see a little bit of learning going on in the people doing pairing. The students that were being experimented on in this particular study, they got better at pairing as they went through a series of exercises. Individuals working alone, the numbers are a little bit more stable. But across the board, we can say a significant difference in the quality of the output from people working in pairs to people working alone. In another study, students working in pairs got significantly better scores on readability, functionality, correctness, and the speed of their execution. Interestingly, though, they also had much higher confidence in their solutions. They graded this as a confidence index of 6.5 versus 3.8. I confess that I'm not sure how you measure confidence numerically in that way, but I'm not a sociologist. This same group also scored the enjoyment of the studies, who graded their enjoyment as 6.6 versus 4 for individuals working alone. So there's something going on here. There's some value. But even if all of this wasn't true, even if pair programming took twice as long and only produced work of the same quality as somebody working alone, I think it's still worth considering. As a leader of technical teams, I know of no better way of spreading learning. And that is deeply important in a discipline like ours that is foundationally grounded in the quality of our learning and adaptation. I've seen pair programming liberate organisations who were formerly chained in single-person silos. It established teams for the first time in those organisations. Pair programming is best practice alongside pair rotation. What we're trying to establish is multi-channel learning across the team. I'm going to get pair with you, you're going to pair with somebody else, I'm going to pair with somebody else, and we all get to learn something from each other. You develop work in pairs and regularly change those pairs is most effective. I've tried over the years some fairly extreme versions of this. I worked on a team once where we decided we would experiment for a couple of weeks with rotating pairs every hour. And it was surprisingly productive, but devastatingly tiring. It wore us out and we didn't want to carry on, but it was very productive. In general, my recommendation is once you get to a certain level of comfort with pairing, try to adopt a discipline of rotating pairs on a daily basis. Every day, the team just reorganizes itself, and let's say that you and I start work on a story on day one. We'll work together on that story, and then in the stand-up for day two, somebody else will come in and join me working on the story. You will move off and work on a different story with somebody else. The following day, if we're still working on the story, I will rotate off and somebody will come and join the person that joined me. This way, over time, for stories that last more than a few days, nearly everybody in the team gets to work on them. Everybody on the team gets to work with everybody else, and so we get to learn from one another. So you get great views of the code base and also deeper understanding of your teammates. Now, this level of rotation is nearly universally unpopular, but nevertheless, I think that it's a powerful technique that it's worth considering. It's unpopular because, for obvious reasons, because if you and I are working on something and it's my turn to rotate off and I'm enjoying myself working with you or working on this particular feature, then I'm not going to want to move off. I'd like to see it through to the end. But the learning that we gain by moving the team around is so valuable that you've got to there's a cost to allowing pairs just to stick together. Human nature is that you will find two people that particularly enjoy working together, and they will tend to stick in their comfort zone and prefer to always work together. There are some advantages to that, but I recommend that you at least experiment with the idea of rotation. If we do this, if we start practicing pair programming and pair rotation, we never have the need for things like handoffs when somebody leaves the team, or the mythical bus problem. We don't have a problem if somebody just disappears from the team because everybody understands the code base. Of course, each individual will bring their own skills and talents to the team, but there is no piece of work, no area of code that somebody else hasn't worked on. Ideally, if you're following my advice and do regular rotation, everybody else hasn't worked on. This is a great advantage. Pair programming is also the best way that I know of introducing new team members. Certainly on the teams that I was deeply involved in, when we built our financial exchange at LMAX, a new starter would come into our team, and on their first day they would work on production code. They would work on code that would go into production the following weekend on their first day. And they would do that. That was possible because we did pair programming, and they would come in, they'd join the team. People did work during interviews because we could do it as part of pair programming. It makes it easy for people to start to understand and navigate the code base. The kinds of things that you learn, though, are enormously diverse in pair programming. Yes, you're going to think about the problem before you and the different solutions to that problem, but you're also going to pick up little tips about, there's this feature in this code base that we could use, or have you heard about this key combination in our development tools that does this particular thing? All of those kind of things are now open to you. It just liberates learning. The organisational impact as a result, is profound. As a leader for an organisation, as I said before, I don't know of a more powerful technique to help teams to learn and to strengthen as teams. The impact allows organisations to proceed more quickly, more efficiently, and with higher quality. There are a variety of patterns for pairing, and I've put some links in the description below to descriptions of those. Most of them involve one person navigating and the other driving, as I quoted from the Wikipedia article at the beginning of this video. One person thinks strategically, where are we going, what's happening next, what does this mean for our design, and so on. And the other person is more in the code, in the moment. What's the syntax for this? How am I going to express this clearly? How could I refactor this to be a bit more pleasant? Those sorts of ideas. And those roles should be aimed to be switched frequently, so that you don't get one person hogging the keyboard or dictating to the other person. This works very well, but there are a few things to look out for. Pairing is strongest when the work is new and challenging. It's when we need to be creative, pairing is the right answer. It's very powerful in that situation. It doesn't work quite so well for drudgery. If you're doing something boring or repetitive, it's dumb to waste two people's time on the boring, repetitive stuff. So my advice is to adopt pairing by default. Assume that the most development will be done as two people working together. But allow it to be okay for the pair to agree that sometimes, if there's something that doesn't require them to pair, it's okay for them to work independently. My advice is to form pairs naturally. Allow people to choose the things that they're going to work on, but strongly encourage the rotation that we talked about earlier. And you're going to need to keep strongly encouraging the rotation, because people will tend to fall back into comfortable habits of not rotating unless you just inject a bit of energy in it. I'm not suggesting that you dictate to people, but just remind people of the value of the rotation. One of the concerns that people who are unfamiliar with pairing often have is a concern about the different levels of skill within a pair. And my experience is that it doesn't matter very much. It changes the dynamic, it changes what you get out as a result, but it really doesn't matter very much what the combinations are. All of them have some value. If you have two experts working together, you get one of two things. Either it goes really fast and really swimmingly, and there's not much debate because it's a straightforward solution and they both see it and they both follow it. Or you have really strong debate over one idea or another. Either way, you usually get a good result from that combination. Experts paired with the novices is an ideal opportunity for the expert to act as mentor and guide. They can instruct the novice and they can help them learn and point out interesting ideas, designs, coding tricks, whatever it might be, to help the novice on their journey. One thing to be wary of with this combination is the expert doing too much of the typing. The danger here is that they're going to rush ahead, leave the novice behind and bored and not learning. So mostly when it's an expert with a novice, it's best for the expert to spend most of the time in the navigator role. I would advise also to watch out if you've not played that role before as expert. Avoid telling people what to type. Allow people a little bit of room to make mistakes. Just having somebody pairing and telling you what the next letter is that you should type is really quite frustrating. So just sit back a little bit, allow people to make missteps. If they're about to move on and they've made a mistake, you could just point it out to them at that point. It's a little bit more friendly way of doing things, I think. The other, perhaps, a combination that is usually of some concern is the idea of two novices working together. And this works surprisingly well too. First of all, they tend to be very supportive of one another, and they're going to be stuck on similar kinds of things, so they can explore ideas and debate things between them, and so improve their learning. If they really get stuck, they can call somebody in to give them some advice, a more experienced member of the team to give them some advice. But two novices working together produce better work than one novice working alone. And as I say, the learning opportunities are quite significant. I've seen this work effectively often. And in the past, we would consciously ensure that not two novices were allocated together to do work. It's often more tricky if they're starting from scratch on something brand new. But if you do the pair rotation thing, you start off with somebody a little bit more senior to kind of lay the ground for the requirement that you're going to work on, and then the next day they rotate off and a novice comes in to work with the novice. That works fine, and is a very effective way of giving the novices more confidence, more experience, and allowing them to trip up and make mistakes and so learn from them a little bit more. As I said earlier, I consider pair programming to be the strongest tool in the toolbox for encouraging learning in teams. As a manager, I think that you would be crazy to ignore it. My observation is that this is the most extreme of extreme programming practices, though. It's the one that gets people the most nervous. It's too alien for most people. Few people like the idea before they've tried it. My experience, though, is that most people, the majority of people, find it a liberating experience once they have tried it. However, there is a small group of people who are never really going to buy in and are always going to hate it. And at that point, the team has some tough decisions to decide about how they're going to cope with that. Do you drop pairing? Do you drop the person? Do you find a way of accommodating the person into the team, even if they're not pairing? Tough choices all, to be honest. I recommend that you simply give pairing a try. Do it for a couple of iterations or sprints, though, not for a day or two. It takes longer than a day or two to really figure out what works and what doesn't. And you're going to make some missteps along the route. Take rotation seriously. I think that daily rotation is probably a little too frequent to start with, but I would recommend that you do aim to rotate at least every few days, every 2 or 3 days. And once you are comfortable with that, then you can speed up to daily rotation, which I think is probably optimal for most teams. If you to follow my advice and try it out, I think you'll be surprised the degree to which most people will enjoy it. They'll be more confident in their work and feel a much stronger sense of team as a result. Thank you very much for watching.